if there is no questions, I will then start my let me share the screen. Yeah, okay, yeah, that was the email I sent you. And then if you go to weekly activities and then I scroll down to week 8 to the 9 combined section, you will see we have the lecture notes ready, and there is no tutorial plan. The tutorial plan is actually generating or making the tables and the graphs that I'm trying to cover in the lecture, or we will cover through the tutorials. I have also made the database, the data set or the data file more suitable to Jamovi, and I need you to to download it into your desktop. Like before this time, it's, as you can see, it's OMV file. You can just simply click on it and open it, and hopefully Jamovi would recognize it. If not, again, you have to go to Jamovi and open the file from there. Okay, so I have downloaded that, and I'll make it ready here in case I need to do something with it through the lecture. Okay, now in terms of the lecture, let's see, this would be my lecture this week. And this, as you can see, we're into the job of bivariate. What do we mean by bivariate? If you remember, the first week we started working with Jamovi. What did we do? Well, we learned how to define the variables. Which variables was a column. We learned and define them in terms of the types of the measurement. The nominal, the ordinal, and the continuous, as Jamovi says, and also the levels of them in case they had categories. Number 1 means strongly agree, blah 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 blah, and we created that, and then the data was copied and pasted out of the Excel sheet. We could also open up the Excel sheet, or we also learned to open up the SAV, which is SAV format for SPSS. So as you can see, when SPSS files, data files, can be opened up by Jamovi. And so these are the things that we learned in the first session. The second session, I said, okay, we have the data file ready. The variables are defined. We also created new variables out of the old ones, and everything was ready for the analysis. And so we said, we always start with descriptive. You remember that the research question, you can see how this is actually correlating with your second assignment. Your research question had a how part and a why part, how open-minded people, and the why, what makes them more or less open-minded. So the how part is descriptive. You describe your society. But when you start describing your society, you normally go and describe it in terms of the demographic features. So our readers would know what percentage of our respondents were male versus female, their educational levels, and where did they live, and their ages, and so on and so forth. So gender, age, all those demographic things can give our readers a view of what kind of people we're dealing with here. And then we moved from the disc, and we used graphs and tables, and we said, graphs are visual, they're lovely, they look beautiful, they're colorful, they give us a visual sense that we humans love. And then tables come and complement them, and then tables would give us more precision, and so on and so forth. And we describe the society one variable at a time, one by one by one, and we started from the demographic ones to what? To less demographic, the ones that are subjective, like how pessimistic these people are, or are they conservative voters or non-conservative voters, what political parties they prefer, a little bit behavioral, right? And you know, how open-minded they are. So you can see we started from very tangible demographic descriptions of the characters in the storybook we are writing together, and then we moved on to explain the society, describe, not explain.
Excuse me, Hamed. Laura says the data set won't open as it says I need a newer version, but can't download a newer version.
Okay, that's something that we are not dealing with. This is not a tutorial. You can communicate with your tutor or with me, and let's see how we can solve that problem. But at the moment, I'm not asking you to follow me by doing anything on Jamovi. This is not a tutorial. I will just teach you how to do the job. When you solve your technical problem for the tutorial, then you will do it practically with your tutor. Okay. So just concentrate. Don't work on the data. The reason I open up and downloaded and I'm going to open it up is because I want to show you. I want to teach you how things should be done. But now, please don't work with Jamovi because that would distract you from the points I'm going to make. Okay, because a lot of it is theory now. Okay, so please be patient. So yeah, the description from the demographic to non-demographic to the subjective, and that was the job we did last week. Now things are getting more interesting. We not only describe the characters in this story, the variables, we also want in our story to talk about the relationship, you know, right? Between Harry Potter and his friends, and Harry Potter and his enemies, right? So this relationship between characters actually it corresponds to the why part. You know, what makes people more open-minded, what makes people less open-minded, what makes people pessimistic or optimistic, and what makes people racist and not racist. So it's you know, this why part of the research question requires us to explore the relationship between variables. How do we do that? Well, we go for correlations. You know, you have heard of that, this very famous motto that says not every correlation is a causation. But we say, yes, not every correlation is a causation, but every correlation may indicate some level of causation. So we first have to find them. So these covariances, these associations between this variable, you know, age grows, you know, it goes up. Would the pessimism would go up too or not? This is called inferral. You know, you infer the direction of causation. And we do that again like before. We do that by using the graphs and by using the tables. Graphs for better visualizations, tables for more precision, more details. Okay, and again, a very strong reason why we are into the job of bivariate or multivariate. Bivariate means, you know, more, you know, two variables, the relationship between two variables. The reason is because we had hypotheses, right? If the why, you have the why question, so you have to also develop the hypothesis. This is exactly what you guys are doing in the second assignment. And then you may remember, these are my lazy hypotheses. You know, younger people are less pessimist, younger people are more likely to be more open-minded, men are more pessimist, women are more open-minded, supporters of political parties with conservative ideologies are less open-minded, and so on and so forth. So as you can see, each one of these hypotheses is connecting one variable to the other one. And the one that depends on the other one is called dependent variable, and the one that explains it is called independent. For instance, when you say younger people are less pessimist, so pessimism depends on age. So pessimism is the dependent variable, and age is what? Age is the independent variable, and so on and so forth. So every hypothesis here connects one variable that is dependent to the independent variable that explains the dependent variable, or we hope, or we speculate that we will explain. So now we are into the job of testing each one of these hypotheses, which means when I say younger people are less pessimist or younger people are more open-minded, that means that I have to go in and find out or explore the relationship between age and pessimism, the relationship between age and open-mindedness, and see if it is a positive relation, if it is a negative relationship, how strong it is and how significant it is, how statistically significant it is. Okay, now, so I use this analogy because it corresponds to our human nature. And we're capable of loving and also hating. So, it's like, these are two characters, these are two variables, and we want to explore their relationships, right? We're a little bit, want to see how things are going between these two couple. And well, the three aspects of the relationship we want to measure or explore are this: first, if if that's is that strong enough or not? If they love each other or if they hate each other, how strong the relationship is. And the second is the direction. For instance, if one side loves more, would the other side loves more in response, or he thinks that he's a very special person and therefore he gets very spoiled and then he starts not loving much more. So this directions, that if with the increase in one variable, with the other variable increases, or with the increase in variable the other one decreases. Is it positive direction or a negative direction? Is it a strong, by a little bit of a love from one side, the other side gets so excited and expresses more love, or not? So that is also the strength. So as you can see, the relationship is in two directions most of the time, especially if the variables are continuous, like age and open-mindedness. And not only that, or it's also the significance. Let's say how genuine these expressions of love and hatred are. How would you measure the significance, how genuine the relationship is? You say, okay, I make a random visit to this couple, and I see, well, they are expressing love to each other, and the more this one loves, the other one also loves, and so on and so forth. So, but how do you know that next time when you visit them randomly again, you see the same story? Maybe next time they are throwing shoes to each other. So that's the significance means, a statistical significance means that in every 100 times you visit this couple, these two variables, the relationship that you detected would be, at least in 95 times, would be almost the same relationship you detected the first time, right? So this is how genuine the relationship is, how significant, statistically significant it is. So the strength, the significance, and the direction, is that a positive or negative direction? Now, if I haven't confused you enough, but maybe this would help. But before I get into a little bit of a more clarification, I just should tell you that the problem we had, the issue that we had in the past, we still have it. The type of the measurement determines the type of graphs and tables we use. You remember when we had, nominal or ordinal, we used bar charts or pie charts and those sort of things. And then we had a continuous variable, we use histograms. Well, here it's the same, but problem gets a little bit more complicated, but fortunately it's manageable. Okay, no panic. So now we are dealing with more than one variable. So we have a combination of the types. So if, for instance, one variable is nominal and the other one is nominal, all that requires some type of graphs and some types of tables or analysis. And if the one is ordinal and the other one is nominal, If the one is continuous, other one is ordinal, and if the one is continuous and the other one is continuous. So you can see different combinations of the types requires different graphs and different analyses. Do I remember that table myself after many years of teaching? Of course not. I have printed out one, or I have saved one in my desktop, on my desktop. And whenever I get confused and I forget and I go back to this, it's like my Bible, little Bible, and I look at it and I get some insights, okay, and say, oh, okay, well, these are my variables. One is nominal, the other one is continuous. Let's go into this table and, oh yeah, okay, I need this one then. So this is kind of a divine rule and we have to comply, otherwise, whoa, bad. Okay, now let's and like many rules, there are of course exceptions, especially with ordinals. As I said, ordinals are kind of they sit between nominal and continuous. So sometimes we say, okay, if the ordinal has about 5 categories, like different levels of education, we treat it as if it's continuous. But you get it in practice, okay? And if the ordinal has fewer categories, like like more conservative, less conservative, we treat it as if it's nominal. So ordinals are sometimes tricky, but we learn how to treat them, okay? Depending on the situation, depending on the context, okay? Now. Okay. Yeah, we have of course different ways of analysis, and we sometimes if both are continuous, or we go for correlation. If there are both are nominal, roughly speaking, we go for cross tabulation or contingency tables, and I'll show you how to do that, don't worry. And if it's one is nominal, the other one is kind of ordinal or continuous, we go for comparing means. So you can keep that somewhere to come back to it anytime you need. And in Bryman, page 340, of course, edition number 5, or figure 15.6, he is providing a table that would tells you what kind of, we need some gadgets. These are the gadgets. These are the measures that measure how strong the relationship between two variables are, depending on the types of the variables. And he has provided that table that I summarized it here for you. But also I have made that table again. This is my version that I think in the past it turned out to be very useful. So you can either keep Bryman's table somewhere handy, or you can keep this table, my table, somewhere handy, just to find yourself out of troubles when you do not know what graph and what analysis you have to go for. Okay, and when it comes to the statistical significance, well, with the strengths, we need this coefficient numbers, and they normally varies, as I showed you in that barometer next to the loving couple. It normally varies between -1 to +1. In some cases only between 0 and 1. The negative doesn't make sense. So anyway, it's between, let's say it's between -1 and +1. The closer you are to +1, the relationship is strong and positive. And the closer you are to the -1, the relationship is strong but negative. And the closer you are to 0, the relationship is weak. But this is about the strength. The significance is about, what if we do the sampling over and over again? Are we going to see the same relationship or not? So I'm talking a little bit abstract, but as I move forward, these things will start make more sense to you. Okay. So here is the p-value. Remember p-value, we talked about p-value, the probability value, or the sig number in SPSS, it's called significance number. It always needs to be less than, you remember that, less than 5% or less than 0.05. If it is less than that, yeah, this is significant. It can be generalized to the broader population. Every time we go not at least 95%, we'll see the same story happening. So it's about, you know, the generalization or how risky it is to make inferences. Okay. Yeah, I don't get into the details of this, you know, where this, how these are going, how these things are going to be tested behind the scenes. You know, Jamovi will do the job for us. I skipped that, but now let's get a little bit more concrete with some good examples. Look at this graph, right? You have on the x-axis, the horizontal, you have, let's say, the hours we spend on social media every week. Okay, and you know, each one of these dots, as you can see, is a person or is a case. For instance, this person spends 10 hours a week, and this is their level of anxiety. It's maybe 1 out of 10 or 12, whatever, out of 10, let's say. And let's say this person, for instance, here, or this person is about 20 hours a week. And of course, the anxiety goes up. It's in the scale of anxiety, 6 out of 10. And this person spends almost 30 hours in, and of course, he or she gets extremely anxious over the week. So if we collect the data, and we have, of course, one column shows the hours people are spending, and another column shows their level of anxiety based on a scale, maybe a Likert scale, and we'll see, wow, which you know, with increase in the hours that these people are spending, and it looks very perfect, right? When in reality it's not like that. That everybody would sit on one diagonal line. It's a little bit too idealistic, right? But just for the sake of simplicity, you see, wow, with increase in the hours we spend, the time we spend on social media, the anxiety goes up. And this is a positive relationship. This is a positive relationship. And as you can see, for instance, when you move from 10 hours to 20 hours, you move from 1 to 6. So that must be kind of a strong relationship. Look at the slope of the line. That must be a pretty strong relationship, especially now that everybody's on one ideal line. That's a very, very strong relationship. And if it is significant or not, that requires some analysis. But this graph, this scatter plot, it's called a scatter plot. This graph at least tells us what's going on in the society, and if you should be suspicious of the relationship between actual hours and anxiety. And it seems that this is worth, you know, testing its statistical significance the next time, and more and more would take samples, you know. And would that result, you know, possibly with the same graph that we see? Now, let's go to the next one. So this is a positive and pretty strong relationship, right, guys? Now, let's go to the next one. And the next one, let's say hours are spent on meditation per month, okay? I'm just making it up. And you can see the level of anxiety starts to drop. So the more we do the meditation, the less anxiety we're going to have. Well, that scale of anxiety is a little bit different now. It's out of 60 or 50 or whatever. But anyway, the point is here that you can see ideally everybody is on the kind of an ideal line, diagonal line, with increase in hours we spend on meditation from 10 hours to 20 hours per month. Then we will see that our anxiety starts to drop. I mean, when I say I mean those cases, you know, that we have measured their anxieties and their hours they spend or minutes they spend on meditation. Now you can see this is what? Increasing variable results a decrease in variable. And that's a negative relationship, okay? Now, you may, so remember, when you have increase or decrease, this is positive relationship because they're in the same direction. They're in the same direction. Look, I could move backward. A decrease in hours is a decrease in anxiety, or an increase in hours is associated with increase in anxiety. So increase is the same as decrease. It's the same. It's the same thing, and it's a positive relationship. But when the directions are opposite, you have a decrease and increase, or increase and decrease. The directions of change between the two variables are opposite. Then we say it's a negative relationship. Some people get confused and they think, when you ask them, how about decrease, one decreases and the other one decreases, and they think because both decrease, so it should be negative. No, decrease exactly means increase. Okay, so decrease, same direction of change, so it is positive. So yes, so when one variable increases and the other variable increases, or one variable decreases and the other variable decreases, it's positive relationship. With one variable increases and the other one does, takes the opposite direction, it's a negative relationship. Again, like when you love your partner and the partner starts to hate you, that's a negative relationship. And so that's the opposite directions, is the negative relationship. Now, how about when you, in reality, as I said before, in reality, people are not really sitting on the same line, diagonal line, but you can actually, that is called line of best fit. You can imagine, and normally when what I do, I close my eyes halfway, like when you look at the stars and try to see if you can find a constellation. Right? You close your eyes halfway and you say, oh, I can fit a line there. This is normally, in reality, people are spread. And you say, okay, so that sounds like a positive relationship between this variable 2 and variable 4, because I can fit a line. But no matter how you try, you cannot find, it's very difficult to fit a line here. When the spots, when the cases, when the respondents are all over the place, so you cannot find. So in this case, you can see this must be the relationship, the correlation must be close to 0, and there is no line that you can fit in there, and you can say there is no relationship, or it must be very weak. If it is difficult to put a line in there, must be, and it shouldn't, the slope shouldn't be too, the slope normally is kind of close to horizontal, whereas when here you can see the slope is like uphills or downhills, and it sounds like a very strong, pretty strong one. Now, okay, how do we do that? Well, of course, Jamovi can help us. You go to a scatter plot, and then in the scatter plot, this is the one that we added. This is the module, the add-on. You may remember we added to our Jamovi, and you go to a scatter plot and you choose, for instance, DEM1, which was I believe it was age, and then E3 was pessimism, and it creates this scatter plot here for you. And if you choose linear, it actually does the job of halfway closing your eye and tries to fit that imaginary line. That imaginary line, the line of best fit here, is that shows, well, when you look at the results, you see with the age, I can see people gets more and more pessimistic. That doesn't mean age makes people pessimistic. Remember, this is not a longitudinal research. We just we're comparing generations practically, or better to say, older people are more pessimistic than the younger people. It would be not good if I say age makes people pessimistic. Maybe when we get old, the younger people now, when they get old, they would stay as cross-generational differences. Okay. And yeah, here is the result. And as you can see that the Jamovi puts that imaginary line, and it shows us a positive relationship with increase in age, the pessimism goes up, or actually older people are more pessimistic, obviously, than the younger ones. And so here, when we do actually a scatter plot, the scatter plot is used when we have two continuous. And as I said before, it's sometimes, pessimism was not continuous, if you may remember, because we had people, as I said, things are going to get much worse and things are getting a lot less worse and things like that. It was ordinal. But because it has about 5 categories or more, we can pretend pessimism is continuous. And then you've got continuous versus continuous, roughly speaking, you can use a scatter plot. It's okay. But if you had, fewer categories for pessimism, it wouldn't really make sense to treat it as if it's continuous. And remember, always input the independent variable age on the x-axis, and the dependent variable on the y-axis. So y-axis is for the dependent variable, and x-axis is for the independent variable, in this case age. And here's Jamovi calls it regression line, we call it line of best fit, and that shows, that gives you a better idea if the relationship is positive, negative, or strong or not. Here I try to do the same thing with using Jamovi with in terms of age and open-mindedness. Well, age is continuous, open-minded continuous, and we'll see that the dots or cases are spread all around the screen. But again, if you close your eyes halfway, you can, like Jamovi, you can possibly fit that line, because the older people on the right hand side are down in terms of their open-minded, they're very close-minded, and the younger and the middle-aged people here are more clustered on the left, and they show higher levels of open-mindedness. So this sounds like a kind of a negative relationship, and that's why we can actually fit the line of best fit. Although you may think, oh, maybe a curve would fit better than a line, but I don't want to get into non-linear relationship. That's for the statisticians, not for us, maybe. Okay, so that's the line of best fit, that because the slope is down, it's downhill. So with increasing one, we see the decrease the other one. So the relationship should be negative and kind of pretty strong, I believe. How do we know how strong it is? Well, of course, we need tables. Jamovi can also add the histograms, those density grams or histograms. On the right hand side, you can see these 2 lumps. You may remember that we showed our society in terms of open-mindedness is divided between 2 groups. Yeah, and that's why you see this cluster here. Let me use this. You see the cluster of people here, and that's why the lump here, and a cluster of people are here, very low in open-mindedness, and this is their lump. This is their lump in the histogram or densitygram. And you may remember that we showed actually in terms of age, we had more younger people than older people, and that's the graph up there. And you can see we have more younger people here, in lower ages. So the good thing about Jamovi versus SPSS is that you can have these things, and then you add more visual understanding. Okay. Wow. Okay. Now the issue is that the correlation and significance. Again, the issue is that if what we see here is statistically significant. If the relationship between pessimism and age, relationship between open-mindedness, age, is that statistically significant? Is that genuine? When we do this, sampling over and over again, do we see almost the same thing or not? And this all depends on the p-value. The p-value, if that turns out to be less than 5%, yeah, that would be significant. That means the null hypothesis, the hypothesis that computer assumes first that there is no relationship, is thrown out of window, and our estimation that this would be the case most of the time, more than 95% of the time, will be the case. So it all gets into p-value. You may detect the relationship. You think, wow, I found a positive relationship, I found a negative relationship. But then the p-value turns out to be more than 5%. And you say, okay, that was possibly, sorry, that must have been possibly because of an accident or something. It cannot be really generalized. Okay. And yeah, okay. So Pearson's R, when you have two continuous variables, Pearson R is the coefficient that shows the strength of the relationship. As I said before, the closer it's to -1, it's a stronger and it's negative. And the closer this number, the coefficient, Pearson R, is to +1, it's a stronger and positive. And the closer to the 0, it would be of course no relationship. If it is between 0 and 0.3 or 30% or 0.3, that's kind of a weak relationship. Between 0.3 and 0.5, medium or moderate relationship. And above 0.5, some of us, we say above 0.6, would be a stronger relationship. And this is called Pearson R. And Pearson R, for when you use a scatter plot and you go to the graph, you go to the tables, you go for Pearson to measure the strength, and you go for p-value to measure this, to understand the significance. Okay, here is, for instance, the table that I have created here out of Jamovi, and then as you can see, between 0 and 30% or 0.3, it's weak or small, we say. Between 0.3 and 0.5 or 50%, it was moderate or medium, and above 0.5 or 50%, it will be a strong or large. So, and this is the Pearson R, right? This is the Pearson R. This is the Pearson R, and it shows that guys, it's negative, right? And it's between ATT, it's between open-mindedness and age. Okay, then one was age, ATT is open-mindedness. So let's see, we have Pearson R, and this gives us the details to the scatter plot we just saw. We saw the relationship, and we saw that it's negative. We saw that with the age, open-mindedness drops, but we didn't know how much exactly, and if this is significant or not. And this little table, very, very simple, super simple, actually tells you what you needed, the details of, the things that you couldn't find out by looking at the scatter plot. Now, the Pearson R, that is, I'll show you later how to do this. The Pearson R is negative 60% or negative 0.613. Okay, and so it's negative and it's a strong. Look, it sits here, a strong or large. It's more than 50%, so more than 0.5. So, and it's negative. That means with age, with increase in age, we have a decrease, negative relationship. Increase in age, decrease in open-mindedness. But again, the $1 million question you may ask me, how do you know how much this is significant, statistically significant? Okay, well, that's why we use the p-value, right? And the p-value here is less than 5%. In fact, actually, I would say it's about 1%, right? So it's or 0.1%. It's much less than 5%. Here, look, it's much less than 5%. So it's statistically significant. This means out of 1,000 times, one time you may not see this relationship, which is great. Okay. And here is how we do. We go to regression, and then we go to correlation. We choose ATT for open-mindedness, DEM1 for age, and we choose Pearson because because these two are actually two continuous variables. If they're two continuous, then we go for Pearson. If one is continuous and the other one is ordinal, as I have said in that table, at the divine table, we go for a Spearman, not a Spider-Man, a Spearman. Okay, and then of course we tick these other boxes, and you can see these are numbers that you just saw in the other slide, and this table will be created by Jamovi for us. And this, as I said, it's negative, it's strong, and significant, statistically significant. So the three aspects of the relationship are just discovered within that red circle: the strength, the direction, which is negative, and the significance of the relationship, which is significant, which is genuine. Okay, and statistically significant. Okay, how about, you may say, how about pessimism and for instance age, sorry, that was, I think, DEM1B was the age brackets, right? Because pessimism is ordinal and the age brackets are ordinal, or you can consider pessimism as continuous, but definitely age brackets or age groups are ordinal. In this case, we go for a Spearman, not Pearson. We go for a Spearman, not a Spider-Man, a Spearman. So when you have continuous versus ordinal, and we repeat that more over and over again, so you will remember this until you go to until your end day. Okay, so when you have the ordinal versus continuous, instead of Pearson, you go for a Spider-Man. Oh, sorry, a Spearman. Now, okay. And here again, as you can see, in this time, I have chosen a Spearman. I have ticked a Spearman because, okay, E3 and DEM1B, I'm treating E3 as continuous, or you can say ordinal. So a continuous and ordinal, it makes a Spearman, or ordinal and ordinal, you need to go for a Spearman. And you can see again, the relationship is positive, pretty strong, right? 88%, 89%. And it's positive, is strong and significant. What does that mean? It means that with increasing age, pessimism increases. How much it increases? As I said before, well, let's call it 90%, 0.9, let's round it 9 times 9, it would be 81. So with 100% increase in age, you will have about 80% increase in pessimism. If you square the correlation, if you square the coefficient, in this case, a Spearman. Okay, now let's move forward. And then you say, well, okay, so far we dealt with continuous versus continuous, or continuous versus ordinal. What if we have, let's say, ordinal versus nominal, or nominal versus nominal? Well, in this case, for instance, consider this one, right? This is, we're comparing men and women, so we don't have increasing gender, okay? So a scatter plot goes out of window. We don't have increasing gender, so we have male and female, and we want to know how conservative they are. I mean, are they less conservative or more conservative when it comes to their voting, right? And as you can see in this case, we're not dealing with continuous variables. We're dealing with how much of what portion of the people are within each categories. So in this case, we go for clustered or grouped bar graphs, and I'll show you how to do that. And as you can see, for instance, here you see 90% of male, the green ones are male and blue ones are female. 90% of them are less conservative, whereas 81% of our male respondents are more conservative, meaning they vote for the liberal and nationals. And the blue ones, if you look at the blue bars, 54% of women are less conservative and 46% are more conservative. What do you understand from this graph? Can we say gender makes a difference? Yes, as you can see, more men are clustered, more men are voting more conservative, 81%. Whereas for women, you can see a kind of a majority of them, 54, are voting less conservative versus only 46% of them. So obviously, from this graph, we understand. You can see a scatter plot is not going to work because we don't have increase in gender. And although less conservative, more conservative is kind of ordinal, but it has only two categories. So I'm treating it like nominal. It only has two categories. So if you got nominal versus nominal, kind of, then you have to go for this grouped or clustered bar graphs. How would you do that? Well, you go again to explorations, survey plots, and then in the survey plots, you put the actually the variable you want to explain, the conservative, them 22b, the conservative one in the variables, and you grouped it. You will group it. This is grouping variable based on their gender, which is them too. So that's why I put gender in grouping variable, because I want to group conservative and non-conservative based on their gender. I want to divide them. And then you choose percentages because that makes more sense than counts, to me at least. And you see this, wow, this is the graph, and that's the one that I explained you in the previous slide. So again, use the independent variable to split the bars. You remember we put independent variable on the x-axis. Here we don't have a scatter plot. We put the independent variable to the group as a grouping variable to split the bars. Here gender is the independent variable because we're explaining voting behavior, conservative versus non-conservative, based on the people's gender. So gender is the independent variable. So we put it into the grouping variable. And of course, that means that we will split the bars based on gender. Okay, but how do we know? Okay, we found a relationship, right? We found a relationship here, but how strong it is, right? That's the question. And is it statistically significant or not? Well, there is no positive and negative relationship because we don't have decrease or increase in gender. So negative relationship is not the case. You cannot talk about it. Although you may say moving from male to female means increase or something like that because it's moving from code 1 to code 2, but forget about that. There is no increase or decrease in gender, so therefore there is no negative. It's always positive. And so this is the chi-square. Again, you became a little bit familiar with that last week. Now we use the power of chi-square tests. And we will see how strong it is and if it is statistically significant. If we go for the chi-square test, it gives us something like this. Again, I'm trying to use my spotlight. Yeah, God, I can't move that. Oh, okay, I did. Okay, now as you can see, it's like the bar graphs, the clustered bar graph. You have 3 males less conservative, 13 males more conservative, 13 female less conservative, 11 female more conservative. And you can see from this, like the bar chart, you can, if you look at this table, you can see, oh, okay, a lot of women are less conservative, whereas here a lot of men are more conservative. So there must be a relationship, you know, female are less conservative, more likely to be less conservative. But as I said before, is this statistically significant? And that chi-squared test would just tell you that, or creates a p-value, and the p-value, see, it's less than 0.05. It's less than 5%. It's 2.5%. So it's significant, right? It's significant. So what we spotted, if you do the sampling over and over again, you'll see almost the same thing. Women are less conservative, men are more conservative in that kind of imaginary population we had. But how strong it is, right? We saw that a lot of men are more conservative, but the female are not that divided. It's 13 versus 11. So that makes things not that strong. That doesn't mean that most of female respondents are less conservative. It's only 13 versus 11, and that actually tones down the strength of the relationship. And the chi-square test actually creates a number that is called Phi Coefficient, or Kramer's V, and that again, it varies between 0 and 1. It doesn't have a negative side because, as I said, there is no decrease in gender. But what we say, it means that, you know, when you move from male to female, that means, you know, let's say in this way, because we know female is more, female is less conservative and male is more conservative. That means that the men are 30, or well, if you again square this, that would be, let's say, 3 times 3, let's say about 9% increase in their conservatism. So it's pretty weak. It's or between weak and medium. I would say the strength is. It's right. It sits on the margin, 0.3. It's around 0.3. So I would say weak to medium, or moderate. Weak to moderate is the strength of the relationship between age. So you can see it's a little bit difficult to interpret this because we're not dealing with increase or decrease. What is important is just to get a sense about the strength. If we had much more female less conservative, compared to the conservative females, this number would have been bigger. I would say, okay, gender would definitely make a significant, a strong, you know, really a strong difference in terms of being conservative or not conservative. But in this case, it's not really making that big, you know, that very, very strong difference. Okay. Okay, how we do that? Well, you go to, again, to frequencies, and then inside the frequencies, you go to contingency tables or chi-square, and then you choose them 22B, which is conservative, and then you put always the independent variable gender into the columns. And you tick a number of other boxes, as I have shown, or in this case, we have chosen political parties and gender. We wanted to see what political parties people are voting for. And this is chi-square frequencies. You go to frequencies, you go to independent samples, chi-square test of association. You choose your variables. Remember, independent variable always goes to the columns. I mean, based on our convention in this course, and you choose chi-square here, that x to the power of 2, it's a Greek letter, it's chi squared, and then you choose that. And there's another, there's a number of other boxes that you have to choose, like Phi and Kramer's, column here, percentages, bar. You can even have bar plots here as well, the bar plot that I showed you before, and then observed counts, and we do that through the tutorials, and you learn how to do that, and that would be that would then create some you know, these tables, for instance, that you can see people are divided between their gender and the party they vote, you know, what percentage of them. And again, here the p-value is less than 5%, so it's significant, and so on and so forth. Okay, so this is the way to do that. So the chi-square and the Phi and Kramer's V are used to measure how strong and how statistically significant the correlations are. So it's called cross tabulation. We don't go for or contingency tables. We don't go for a scatter plot. As I said before, these are not continuous, and therefore scatter plots are not useful. So we just put them into frequency tables or bar graphs, and then we group them based on the other variable and see what percentage of male are voting in what direction, and so on and so forth, versus female. Okay, here look at this one. This is the graphs are created again, and I have made some of the interesting numbers red for you. First, the frequency tables here, the party preferences versus male and female. As I said, we always put independent variable, in this case gender, in the column. So male column, female column. And the dependent variable is the party preferences. We wanted to know, you know, in what parties men vote and what parties female are more likely to vote. So as you can see, 41% of the female, you know, you can see the percentages are divided based on the column. These are 100% women. Out of 100% women, 41% of them vote for the Labour Party. That's why they're less conservative. And then only 12.5% of them vote for the, 41% of them and 12.5% of them vote for the Labour and Greens, and that's why they are less conservative. Whereas if you look at the men here, you see that 31% of them plus 50% of them are voting for Liberal Party and National Party. So you can see more men are clustered around Liberal and Nationals, right? So this would tell us there must be a relationship. It seems that the type of parties that females are interested are different. You know, you can see the numbers are bigger, are different to the type of parties that men are interested. You see, the clusters are not on the same rows, same lines. But then you say, is this a statistically, is this the relationship, this difference between men and women in terms of party preference, is that significant? Is that a statistically significant? Well, say, okay, chi-square test will give you a p-value, right? Or in SPSS, it's called sig number. Significance. So if that p-value here is, as you can see, very close to 5%, but it's still less than 5%. It's 4.6%. It's 0.046. So it's less than. Then we can say, well, okay, that's significant. That can be extended to whole population. It can be inferred, or it can be generalized. Okay, now. How strong this difference, the difference here is. As I said, we don't have increase in gender or decrease in gender. We don't have increase in political party preferences or decrease. Here is just a matter of the strength of the difference, not the strength of correlation, the strength of the difference. The difference we spotted, how strong it is. Is that make a big difference to be male or female in terms of political party preference or not? And here you can see the Phi or Kramer's. They always create both of them at the same time because there's one box that you tick, and it's 0.448. So as you can see, this is sitting between 0.3 and 0.5, close to 0.5, I would say medium to strong. Yeah, it's close to 0.5. So it's medium to a strong or moderate to a strong relationship between the two variables, or it's moderately to a strongly makes the difference if you are male or female in this story in terms of your political preferences. These are all about likelihoods, remember. It doesn't mean every female is less or votes for this party. It's just the likelihood. Okay, now how about for instance yeah, and the less conservative and more conservative. And again, this is I have explained it. You can see 13 female voting for less conservative versus 13 men voting for, and the percentages you can see. And again, it's significant. You know, the p-value is significant, and the phi would be, the value of the phi would be -35. That means that you know, moving from male to female makes you less conservative. That's why it's negative. Okay, now look at this one, for instance, gender and pessimism. Again, I'm treating pessimism, as you can see, we treated pessimism as continuous, but now we can also, because it's ordinal, we can sometimes treat it as categorical, as nominal or ordinal. So in this case, again, chi-square, it could be, you know, frequency table, it could be one way of showing the relationships. You can see that I have made this red, you know, a lot of women are saying the situation is going to be much improved, a little improved, or the same as not. They're showing a little bit of, you know, more optimism. Whereas men here, you can see that most of them, a lot of them, have ticked a little worse and much worse. So they're showing more pessimism compared to women. So we have detected here a relationship between two variables, pessimism and gender. We can say, based on this frequency table, divided based on gender, of course, it seems that the females are more likely to be optimistic compared to men, according to this distribution of the percentages or frequencies. Now let's see what the other tests would tell us. As you can see, the chi-square test would tell us the p-value is very much, you know, very small, much smaller than 5%. It's it's 0.005. So it's definitely significant, it's statistically significant. The differences between the genders in terms of their pessimism can be extended to the broader society. How about the phi? The phi would say it's 0.611, and it means that actually it's pretty strong relationship. That means moving from male to female, it makes people very optimistic, you know, strongly optimistic. So the difference is kind of strong in that sense. So the phi is the strength, or Kramer's V, the same number as you can see. So it's a strong, it's significant, the differences we spotted between male and female in terms of their optimism. So your gender would make you strongly optimistic, according to these findings, which are fake, of course. Okay. How about then you say one variable is categorical, like nominal, for instance, and the other one is continuous. Like, for instance, I have two classes teaching two classes, and one class, their performance is the final grade out of 100, and the other class is again their performance out of 100. So I have two categories, one class versus the other classroom, and the other one, their performance, the final grade out of 100 is continuous. How about that? I mean, you can't go for frequency tables. That would create a very lengthy columns or rows. So is there a solution to that? What graphs should we go for, and what tables should we go for? Well, in that case, actually, we go for something that is called box plot, my favorite. So box plots are interesting because, as you can see, they're halfway between frequency tables and histograms or scatter plots. So you can see ATT on the y-axis is the dependent variable. It's open-mindedness. On the x-axis, we have male versus female. So you don't see an increase or decrease. Just these two categories, right? Two classrooms or two courses or two genders. And then it shows how people are spread in terms of their open-mindedness within each category by showing these boxes and whiskers. Okay, well, what does this, first thing first, what does this mean actually? Well, the line that is normally somewhere within the box is the median. Median, you remember median, 50% below, 50% above. It's not mean, it's median. So just, and so if that line is median for women, and this line is median for male, what does that mean? Well, if you look at it here, 50% of male people are showing a very low level of open-mindedness, right? So if that's the median. Whereas the women's median line is well above males or men. So it's around 3 point something. So obviously this graph very quickly just tells us that the females are actually more likely to be open-minded because their median line is well above the median line of men. But the test that we do does not compare median; it compares means. But but it's not a really big difference. So in box plot we compare medians here. The good thing about Jamovi, actually, it can also show the mean, but I don't want to make things more complex. So anyway, so women's median, that means 50% of them are below or above 3 out of 4 in terms of their open-mindedness, and the men are very much lower. So obviously women are more open-minded. But what does the rest of these boxes would tell us? Well, this is the bottom whisker here. It's the bottom 25% of them. So the bottom 25% of women are actually sitting between 1 point something and 1 point something. So these are the bottom. This is the bottom 25% of women, and the lower part of the box is the second quartile, and that's the second bottom 25%. Here is the median, which is the 50%, and here is the top whisker would be the top 25%. Okay, so 25% of the women on the whisker, top whisker, then another below 25%, then another 25%, and then 25%. So it divides the whole population of females between these 25% divisions or quartiles. So the first quartile, second quartile, third quartile, and the maximum and minimum, as you can see. So the whole box even is above for women. Even the whole box is above the box for the men. So it's not just their median, but actually most of them are above in terms of their open-mindedness. Okay, now let's go to the next slide, and that would tell you how to make these beautiful box plots. And then you go to descriptives, of course, and then you choose descriptives, out of the explorations, and you choose ATT, which is open-mindedness, is the variable. How do you split it? Of course, by gender. So the independent variable goes to a split or group. So remember, always split using the independent variable, which of course that means that the independent variable goes to x-axis, and the dependent variable, which is open-mindedness, goes to y-axis. And as you can see, these boxes, women's box, and the whiskers are well above the men's box. And you choose, of course, here you can choose box plot to generate the box plots. We're using the descriptives. We have used that last week, if you may remember. And as I said before, the more you practice, the more you will remember where to go and what to do. Okay, and here is the point. Use the independent variable to split the bars, or here gender is independent. Okay, now I did the same with the more conservative, less conservative, and the beauty of the box plot is that it can also find the outliers, right? The outliers are so annoying. Someone just, ticking every box on the right, or to having extreme views. And normally these people that show extreme views, or just simply are lazy and they tick all the boxes on the right hand side or left hand side of the scales and things like that. They can be actually detected, and they can be we can sometimes, depending on the theory, we can actually ignore them in our analysis, and that gives us a better understanding of the reality. Sometimes, you ask people to evaluate the courses, and someone really hates you for any reasons and just ticks everything negative against you. That would be an outlier. For obviously they don't have a very realistic understanding that courses and teachers could be a mixture of both good things and bad things, and no one is devil. Or someone is really love that course and ticks everything, positive, and again they become outlier. So how does that detect the outliers? So if you measure just roughly speaking, by your eyes, you don't need to bring a ruler or something. The size of the box, multiply it by 1.5, 1.5 times bigger than that size, and go down. Okay, that would be here. Here we call fence, the fence. 1.5 times lower than the size of the box, and any case outside the fence is the outlier. The good thing about SPSS, it tells you what case it is. For instance, when I use SPSS, it told me it's case number 8, and if I want, I can go and get rid of case number 8 and consider his or her answers as missing. And here, among the more conservatives, we have actually SPSS can tell me there are 4, not just 1, and it gives me their numbers. But here, as you can see, unfortunately, Jamovi doesn't do that, or I don't know how to do that. And again, as you can see, you multiply the length of the box for more conservatives and go up. So 1.5 times, 1 off. And here must be the fence, the imaginary fence. And these guys are outside. There is actually more than 1. They are outside the fence. So they must be the outliers. How do we know where does 1.5 comes? That's not among the 10 commandments to Moses, okay? It's just a conventional. The convention is that we consider that those people outside the fence this way, by considering 1.5. Okay. This is again just to show you, give you a better understanding of these boxes, quartiles, not the first one is at the bottom 25% of the data are below. The median is 50% below, 50% above, and the third quartile have 75% below, 25% above the quartile. And if you look at this open-mindedness, I'm not asking you to generate, this is just for your information. You can see this is the box plot for the open-mindedness and how these individuals are spread. And then you can see that median is here. This is the bottom 25%, second 25%, third 25%, and the top 25%. And as you can see, we had two groups of people in that histogram or density graph, and that's why see these dots here are clustered, and these dots here. So this is a divided society between highly open-minded and highly closed-minded people, and that's why this box plot is spread all across. And just to give you another visual view, from another angle. Okay, I did the same with open-mindedness versus gender, and as you know, this is what we discussed. The median for the female is well above males. They're more open-minded. I thought, how about age? How about age? And then he said, okay, I had age groups, right? Age group. Now I'm treating age groups as if they're nominal. They're just groups. Okay, and you can see that the older people, their median of open-mindedness is lower than the median of the middle-aged people, and theirs is much lower than the median of the younger people. So obviously, again, this tells me, wow, there is a negative relationship between age brackets or age groups and open. Okay, so that's the age brackets and open-mindedness, and you can see the box plots are actually telling us a story. But then we want to go for the precision, and what would be the tables for that? Okay, this is another one. For instance, the political party preferences and pessimism, and you can see those who are voting for Labour Party are much less pessimistic. Those voting for Liberal and National are more pessimistic, and those voting for Greens are a bit less pessimistic. Remember, we had a hypothesis. We said those in opposition, those who vote for the parties in opposition, are more pessimistic because they think, the party in power is just messing up. But this doesn't show. I mean, if let's say this is happening now, let's say Liberals and Nationals, ScoMo is in power, we know that, and we see that actually, wow, that the hypothesis is the opposite of that is happening here. Actually, the Liberal Party and National Party voters, despite the ScoMo being in power, are more pessimistic about future, whereas the opposition, people voting for opposition, they are actually less pessimistic. Okay, how about this one in terms of education, right? Again, you can treat education like a continuous one, but ironically, just to show you the box plots, because I love them, I'm treating them as if they're categorical or nominal. And here is open-mindedness. And then you can see that those who are on the higher levels of education, their medians, their boxes and their medians are actually, here the median is on the top. So they actually are showing higher levels of openness. And the less educated people are showing pretty the same level of open-mindedness, but much lower than. So what makes the difference is here from complete secondary school. When you complete your secondary school, you became, wow, you're so enlightened and open-minded. Up until there, I mean, this is an imaginary society, of course, and up to this point, people remain kind of less open-minded. Okay. Now, how about more precision? You know, these age groups, okay, we said we can, you know, the box plots compared medians, but when you go to the tables, you compare means. And you can see in terms of open-mindedness, you see that the level of open-mindedness for the a younger group is 3.25 or 26 out of 4. It's pretty high. For the middle-aged people, it's 2.26, which is much lower, as that's why I made the color a little bit less colorful. And then for the older people, it's 1.6 out of 4. So as you can see, the level of their mean, the average open-mindedness in each group drops compared to the previous group, from younger people to older people. Again, you always ask me the $1 million question, how significant it is, and I show you the p-value or the sig value significance here, the p-value, and it's 0.000, much lower than 5%. So it's what the difference we see is a statistically significant, and it can be generalized to the broader society. Then you say, okay, now we have, but now we see this is significant. How strong it is? Well, we can go to well, this when you compare the means, it's called ANOVA in Jamovi. There is you go and you can create something that is called ATA. Again, it's another Greek letter. I hope there will be no virus called ATA coming. So it's 0.625. If you may remember, in that range, it shows a strong relationship, And if you square ATA, it's about, you know, about 40%. You don't need to square it by using calculator. It does, you know, SPSS does that. I hope Jamovi would do that too. So this is about 40% increase. So with 100% increase in age, which means moving from one category to the next, you will have a kind of a 40% drop. In this case, drop, because we see it's dropping 40%. But ATAR doesn't have negative values, unfortunately. So 40% drop in their open-mindedness. So this is the strength. This can explain how things happens. This is the significance, and this is actually what happens here. A comparison between the average open-mindedness of different age groups. Isn't that interesting? That, you know, this reality that we discover, isn't that beautiful? That you can actually find out, you know, in reality, you know, how people in different ages, different levels of education, how they are actually looking at the world and what they think of the world and how they behave. And this is the beauty of the quantitative. You know, it requires some hardship to get there, and we have computers helping us, and we know that quantitative also has its own limitations. But never think that because quantitative research has its limitation, so qualitative research is godsend. No, qualitative research also has its own problems as well. For instance, you can hardly generalize anything out of qual. Even generalization out of quant is problematic, let alone the qual. Okay, how do you do that? You go to ANOVA, one-way ANOVA. You put again open-mindedness, the dependent variable there. You use independent variable to split or to group, and you tick this little boxes. And then here's the p-value, and here are the means across different age groups. It's exactly those tables that I showed you, and here is the process of doing that for this, comparing the means, comparing the averages of different groups. Okay, and this is what I just showed you. I don't know why I put it again here. Oh no, sorry, that's not age groups. These are the different political party preferences, And again, you can see the differences in terms of open-mindedness. Those who voting for Labour Party are and Greens, they are showing higher levels of open-mindedness, right? Higher levels of open-mindedness. And the Liberal Party and National Parties, lower levels of open-mindedness. Is this significant? Yes. And how strong it is? Of course, these differences obviously very strong, 0.8. And the differences when you move from one category to the other one, from the bigger, with a category with higher open-mindedness to lower or vice versa, it's about 66% difference in average, in roughly speaking. Okay. Yeah, I think one more thing, if you still don't have headaches, I want to make sure you will have. Sorry. And this is not what we do, but it's just to tell you things can get even more exciting. Sometimes, for instance, you find, you think that, people's income increases their voting, influences their voting behavior. But then you say, what if this is a spurious? What if it's a fake relationship? I mean, you might remember, when I said, for instance, the fan relationship between the type of the pet people have, cat owners versus dog owners, and their voting behavior, and then realize that actually maybe it's socioeconomic that makes the real difference, not the pet, not the dog or the cat. The same here. If we can, for instance, I showed you in the scatter plots, if you may remember, the more pessimistic people are, the less open-minded they were. But we have difficulties explaining how pessimism makes people less open-minded, and we can't explain it. We become suspicious. Maybe this is spurious, and then you say, okay, let's bring age to the equation, and keep the age constant, okay, and see if that makes a difference or not. When we say keep the age constant, means that you look into one age group and see if there is a relationship between pessimism and open-mindedness. If there is no relationship, that means age is actually playing a role in here. So I did that, actually. I did that. You may remember this is the correlations between pessimism and open-mindedness, and we said, it's a pretty strong and negative relationship, means that the higher is pessimism, the lower is open-minded, and it turned out to be statistically significant, right? It turned out to be statistically significant. But then we started to have some doubts and said, what if we keep the age, and that's called partial correlation. What if we keep the age constant and see what happens between open-mindedness and pessimism? And this is what happened. It's negative, it's very weak, and is the p-value is not less than 5% anymore. So that means the relationship between pessimism and open-mindedness is not significant and is not as strong when you keep the age constant. And that means that it's the age that makes, go back up here, it's the age that was making pessimistic, and it was the age that at the same time was making people less open-minded. And that's why we saw that relationship between the two. It was actually age behind the scene. So this is called multivariate. I'm not asking you guys to do that, but if anyone extra, interest, you can do that here, and even you can see the scatter plots and things like that. That's for those who are extra interested. So now I get back to hypothesis we had. We saw younger people are less pessimistic, yeah, and it was significant, right? We saw that younger people were more open-minded, and it was significant, statistically significant, pretty strong. You remember that? We saw men were more pessimistic. So you can see hypothesis 1 proved right, hypothesis 2 proved right, hypothesis the other 2 proved right. Hypothesis number 3, women are more open-minded towards immigrants. That proved to be the case. Supporters of political party in opposition are more likely to be pessimistic. You may remember that was not the case, actually. The voters for the political parties in power were more pessimistic. So H4 rejected, and it was the opposite. So we have to correct it. Now we have to say supporters of the political party in power are more likely to be pessimistic. So, and you can see the data is not correct. We revisit our hypotheses. We just didn't make up those hypotheses for fun. We're just coming back to them and revise them in the light of the findings, right? And then hypothesis 5, supporters of political parties with conservative ideologies are less open-minded. Yes, we saw that. It was strong and significant, statistically significant, if I remember correctly. H6 or hypothesis 6 would say people with higher levels of education are more open-minded towards it. We saw that. You remember those box plots. The more pessimistic the person is, the less open-minded. We also saw this one, but remember that when we brought age, it appears that it's actually it was age that made people more pessimistic and less open-minded. And although this appeared to be statistically significant, hypothesis number 7, and it appeared to be a strong pessimism making people less open-minded, but actually that was spurious. It was fake. It was actually, it was like, you know, relationship between pets and your voting behavior. So it was actually age that made people more pessimistic, and it was age that made people less open-minded. And as the result of that, we thought that there is a relationship between pessimism and open-mindedness. So you can see the whole theory in the light of the findings can be rewritten. Some of them, most of them prove to be the case. Some of them prove to be not to be the case, quite the opposite. And one of them turned out to be, in the first place, turned out to be the case, but it turned out to be spurious or fake. So it's really interesting to understand the society instead of a little small group that you sit and interview with them and ask them about their whole stories for hours and take notes of them and transcribe them, which is another beautiful thing to do. But we humans live in huge, big societies. We humans also need to understand what's going on at the macro level, at the big picture. We humans not only need microscopes to look deep into the people's minds and stories, which are very exciting, of course, and many people develop so much of interest in them because they sit together with people and listen to their stories and wow, interesting. But also we humans need to have telescopes and look at the galaxies, right? And here is quant for those who want to do cosmology in social sciences. All good? So, okay, I don't think I have time to practically do the Jamovi. I'll leave it to the tutorials, and in the tutorials, we record that. We go through this in as many tables and as many graphs that we want I have covered. We will cover this session this week and the next week, okay? And then of course that would before the mid-semester break, we have actually learned all what we needed to learn about Jamovi, about the stats and things like that. And after the midterm break, mid-semester break, we come back. That would be week 10, 11, 12. And I'm hoping that we can also add another week. It was not supposed to, but now things are delayed. I'm happy to add another week of learning and maybe push the final assignment a little bit further back. So we will have about four weeks hopefully of working on the final assignment to make sure that those who attend will definitely pass that final assignment. Okay, for this week, yeah, this is the data you download and work with your tutor, creating those graphs and tables. And this is the output. Don't click on that output now, but when you do the job, you can then go and compare what you have created with the output I have created. And the good thing about Jamovi is that this output, when I click on it and open it, let me do that now. We still have a few minutes. Yeah. Yeah, see, these are the things that I have created, and you can compare. You can see if you could create them through the tutorials as well. But the interesting thing is that Jamovi can let you do reverse engineering. Actually, you can see what I have done by clicking on each one of the graphs that I have created. You can see where I have gone and what I have ticked and what I have put into those boxes, and all my secrets are there for you. So even if we didn't have time to do this, you can also always come back to the output and do a reverse engineering and take notes. Okay, Hamed's gone to a scatter plots. The scatter plots were there here, and Hamed has put them one age here and E3 pessimism, and he has ticked linear and non. And this is what he has created. This is why what he has created. And then you scroll down again. So this is a bit of a a reverse engineering. So you can see, okay, okay, this is about open-mindedness and age. And let's see what Hamed, I forgot what Hamed said, but let's see what he has done. And you click on that, and Jamovi reveals my secrets to you. And so again, you can see a scatter plot. Age is there on x-axis because we said it's independent variable, and then total open-mindedness goes here on the y-axis, and then it's linear, and so on and so forth. And then you scroll down, and oh yeah, that's the correlation matrix he was talking about. I forgot how to make it. Okay, let's click on that, and you can click on this, and you can see, wow, I have gone to correlation matrix, and correlation matrix is in regression. Actually, if you play, you can find it. Correlation matrix is here, okay, and Hamed's possibly is gone here, and he then has put ATT, total openness, and age. You can see I have changed the names, so they're not those spiritless titles. Now you have the names, the real names of them as well. So to total open-mindedness, and he has put them there, and then he has ticked Pearson. Why he has ticked Pearson instead of a Spider-Man? Well, maybe because he said if they're too continuous, we should go for Pearson. Oh yeah, that makes sense now. And then you see the Pearson is negative 0.613, and it's the p-value is less than 5%. And when you say flag significant correlations, actually it flags it. Those little stars here, that shows that it's very significant. It flags the significance. So even if you have forgotten that this should be less than 5%, even if you have forgotten, those little stars here, if you do the flagging, those little stars would tell you, wow, this is significant, statistically significant and negative, and pretty strong relationship between age and open-mindedness. Then you go down maybe later, and you can see here again another one. This is open-mindedness and age groups. And then you ask yourself, wow, why Hamed put, ticked a Spearman instead of Pearson? Why he changed his mind? Oh, maybe that's because the types have changed, right? You have the continuous versus ordinal, and that's why he chose a Spearman. And again, it's kind of negative, pretty strong. It's only age groups. The reason that I replaced age with age groups just to show you when it becomes ordinal. you need to go for a Spearman. Better to go for a Spearman. Conventional again. And then you go down here and you see again pessimism and age groups, and click on this and the secrets are revealed. You go here, click on that. This is the conservative versus non-conservative, and male and female, and the bars, the clustered bars or grouped bars, and this you can see, wow, Hamed's gone to survey plots. Where were they? I mean, you just go here and then, oh, that's here, survey plots, right? Survey plots are here, and yeah, you can see that I have put conservative in the variables, and I use gender as independent variable, and I put it into the groupings. So as I said, the independent goes to groupings because we want to split the bars using the independent variable, in this case age. And then you go down again, another contingency table, and this one has even percentages of people in each, and it's chi-square, and this is for more precision. And you can see that, oh, Hamed's gone to contingency tables. Where are the contingency tables? I can see frequencies, so it must be in frequencies, right? And then you go there, and then yeah, frequencies. Isn't that the two? Oh yeah, this one. This is the one he was talking about. So independent samples, chi-square taste of association, and that gives you this. And Hamed's put conservative on the rows, and gender in columns, and let's see what things he has ticked here. Oh, he has ticked this one, this one, this one, and this one. Phi, yes, that's what he was talking. Phi and Kramersby, that tells us about the strength of the relationship. And okay, now I see how people are divided in terms of gender and their conservative behavior. And also, this is the p-value, much less than what, 5%, so it must be significant, and it's a medium to strong relationship, as I can see here. And if you go to the plots, even you can see that you can have these plots, but I don't like them. But anyway, you can see again the less conservative, more conservative female versus male. And again, you can do reverse engineering and see what has happened. But we will do that before. Don't do that now. Don't do the reverse engineering now. First, go to your tutorial, learn how to make these. Later on, over the mid-semester break, if in case you don't know or you forgot and you don't have time to watch again the tutorial or the lecture, you can come here and do some secret revealing. Okay, I think it's more than enough for me. I'm sorry